So today is binomial probability, and this is the first time when, you gotta remove the headphone please, when you need to use a formula in order to get the answers. So I think it's actually a really cool example. Basketball. You either make it or you don't. Get by means two. There's only two possibilities, and this is when you can use the binomial. You can't use it when there's like an in-between. Like, I tried dog and cat the other day, but do you get, some people have a dog and a cat, and that messes it up. So you can't just, do you have a dog or do you have a cat? Because that wouldn't work for binomial. Because you might have a dog and a cat, and that's like a third possibility. So it only works when there's two possibilities. But do you get in tons of sports? You either make it or you don't make it. It's like one or the other. You don't get like in between. Okay, so then for basketball, let's say that you have free throws at the end of the game. A lot of times the game's really close and one team's ahead, and so they foul the other. The other team fouls them because they want to try to get some extra shots in, some free throws to try to like get it over the top. So at the end of a game, there can be, if one team's ahead, there can be lots of fouls and there's lots of free throws. All right. Would you agree that you would expect an 80% free throw shooter to make 8 out of 10 shots? But I'm going to show you that if an 80% free throw shooter shoots they get 10 shots, they will not likely make 8 out of 10, even though they're an 80% free throw shooter. It's so weird. All right, because they might make more or less than 8, right? So the odds of them actually making 8 shots is really low. All right, so I'm going to jump right to the formula. Are you ready? Put a C, put 2 sets of parentheses, and this is a choose thing. So the example I gave is you got an 80% free throw shooter. Well, right away, you label this as 0.80, and that's make. You should label it so you know what you're doing. The 80% chance of making it, well then, of course, I bet you just by using logic, you can tell what's going to go here. What do you think? 0.20 and what? Miss. Now, I said that this person's going to get 10 shots at the end of the game. They get fouled a lot, okay? And actually what usually happens is they try to foul the people that are really bad free throw shooters. That makes sense. You don't want to foul the person who's really a good free throw shooter, but let's say that an 80% free throw shooter is actually like the one who's getting fouled all the time here. So there's 10 times they're going to get a shot at the end of the game. And we're going to choose, take a wild guess what number that is. 8. Now wait, there's one more thing you have to do before you actually do all of these calculations, and that is we have to put a power here and a power here. Why? Because you're going to make 8 of them, so it's 0.8 is to the 8th. It's like you're going to multiply a bunch of 0.8s. Would you agree 80% chance they're going to make it? Another 80% chance they're going to make it? And then there's another 80% chance they're going to make it? And you keep on multiplying those out 8 times. And then the last piece, I bet you can figure out. What do you think the last thing is? There is a 2. Where? On the miss. See, they're going to have 8 makes and 2 misses. So that's 8 0.8s and 2 0.2s. Now, I'm going to try to break down where this came from again with a coin flip. You guys all know you got a 50-50 chance of guessing heads or tails, right? So if I said I want heads and then another heads, you do 0.5 times 0.5. That's 1/2 times 1/2. Do you get that would come out to 1/4? AKA 1/2 times 1/2 equals 1/4, which is 0.25. Is that making sense to you? That's 2 heads in a row. See how I had to multiply them together? What if it was 10 heads in a row? Will that be 0.5? Do I really want to write it 10 times? No, I could put it to the 10th. See what I mean? That's like 10 heads in a row would be like that. That's why we have these powers here. It's like we have 80% chance, we got 8 of those. 20% chance, we got 2 of those. But why the heck is this thing here? Let me explain. That's how many ways you could make them or miss them. Let me just write out one of them. Here's one way. They get their 10 shots. 80% chance because they made it. What if they missed their second one? Then they made their third one. And they missed their fourth one. And then they made all the rest of them. Do you get, I'd have to do that. I'd have to have 10 parentheses there, and that's one way they could have made them and missed 2 of them. But couldn't they also have started with a miss? And they could have also had another miss. And then all the rest of them could have been 0.8s. They made like a ton of them in a row. ... Do you get, this is one way to do it, this is another way to do it, and there's a ton of ways. How many ways? That many ways. That you could arrange your 0.8s and your 0.2s, but there'd always be 2 0.2s, because that's 2 misses, and 8 0.8s. All right, now these are actual numbers from a calculator, so this is the part where you got to know how to put that in the calculator. I showed you it's under the math menu, under the PRB for probability. And get a number for this, get a number for this, get a number for this, and you multiply them all together. I'm going to pause for a second while you actually get the final answer. All right, so 10C8. If I have the old style calculator, I got to type the 10 first. And then I go math, PRB, and a C, and then an 8. And it says 10, NCR 8. And the answer is 45. Raise your hand if you had 45 for that part. Okay, good. Then 0.8 to the 8th is going to be big. No, actually going to be really small. 0.8 to the 8th is 0.1677. Now be careful, because you really shouldn't round in the middle of the problem. So I'm going to use that whole decimal, 0.16777216. I'm going to use that whole thing because I don't want to round in the middle of a problem. So I'm going to say times 0.2 to the second, and the grand total I get after I times all 3 of these together, including the 45, is 0.302. Can anybody verify 0.302? You guys did it perfectly. Good job. Wouldn't you agree that if you asked a friend, even a friend who's good at math, you've got an 80% free throw shooter, they get 10 shots at the end of the game, what's the probability that they're going to get 8 out of 10? They would have thought it was a pretty high chance they were going to get 8 out of 10. But it's actually only a 30% chance that they're going to get 8 out of 10. Why? Do you get there's also a pretty good chance that they'll get 9 out of 10. And there's also a pretty good chance they'll get 7 out of 10. And there's also a pretty good chance that they could get 10 out of 10. If they're an 80% free throw shooter and they come through in the clutch, that could happen. So this 30% goes along with all the other things that could happen, and all of the things that could happen add up to 100%. So this can only be 30% of it, because like 25% chance that they're going to get 9 out of 10. And there's like a 25% chance that they're going to get 7 out of 10. And then there's like a 15% chance that they're going to get 100%. All of them. They're going to make all of them. So to me, this feels really counterintuitive. Only a 30% chance that they'll exactly get 8 out of 10. Now, this is important. Pay attention. One of your questions is going to say, what's the probability that they make at least 8 out of 10? Would you agree that means 8 out of 10 or 9 out of 10 or 10 out of 10? All right, I don't want to do that one right now because it's going to be really complicated and take us a long time. So I'm going to change the question. Now we only have 3 shots. All right, in hockey, I was a basketball player, so I am not as good at the hockey analogies, but I think that there's a possibility where a person could have things that are kind of like a free throw, but in hockey. What would you call that?
Shootout.
A shootout. Okay. So like you get your chance, you skate down, and you got to either score or you don't. Would you agree that that is a binomial scenario where the kid's going to either score or he's not?
Yeah.
Okay. So let's say that you get 3 chances. You're doing a shootout scenario. You get 3 chances. I'd like you to figure out, oh, and also tell me if you're, it sounds like you're a hockey player. What would you say the chances are for a good player to score in a shootout? Is it like 50-50 or is it better than that?
Depends. If he's like a really good shootout, like shooter, maybe like 70.
Maybe like 70. Okay, good. We'll go with 70% chance of making. See, there's a 70% chance you're going to make it. Well, I'd like you to do one of these things with the C and the 2 parentheses for that, and let's figure out the probability that you make 2 out of the 3. If you're a 70% shootout maker, then what's the probability you get 2 out of 3? Mr. Hawks, can you tell me what goes here and here? Here and here.
27
To the,
7 power.
there's only making 2 out of 3.
Oh, 2.
Okay, all right, so this is the make. And what's the other one?
23.
0.3. And it's to the what? If you make 2, you're gonna miss 1. There you go. And since you're on the spot anyways, Mr. Hawks, can you tell me what goes here and here?
2 and 3.
Yes, this is a 3 and this is a 2. Very good. Use your calculator. Figure out that answer. Anybody else get 0.441?
Yeah.
Sweet. Okay, now, I'd like you to clear up your work. Normally I like to see work, like on the test, you need to show me your work, but just write it like this. That's the probability of making 2 shots. Now I'd like you to figure out underneath it the probability of making only 1 shot. You would think, since they make 70% of their breakaways, that they would probably make 2 out of 3. But what if they made 1? Figure out that probability. I got 0.189. Can anybody verify that? Sweet. Now, here's the hardest kind. Now that I've done all of this work, it's not that hard. What's the probability that he makes 2 or 3 out of 3? Have you learned by now that or, you just add them together? So then that's together. I'm not even actually add them, so I'm using my calculator. 0.63 is correct. Would you agree there's a 63% chance that he'll make either 2 or 1 shots? All right. Cool. That's called the binomial. All right. Here's one more edge case. That means like weird one. It's kind of like you have to think differently. Back to the 10-shot scenario. What's the probability that they make at least 1? Now we're going to go with an 80% free throw shooter. They're an average 80% free throw shooter. They're going to take 10 free throws. And the probability of at least 1. So then you have to figure out 1 and 2 and 3 and 4 and 5 and 6 and 7, 8 and 9 and 10 and add them all together, and holy crap, that is so much work. So there's a smart way. What do you think?
Could you just figure out like the probability of him making 0 and subtract it from 1?
Yes, exactly. Find the probability that you don't make any. That's the only thing you're not adding up. Find the probability of 0, but the key was what you said at the end. So Anders, you said it perfectly. Find the probability of 0, which will be like this. I have 10, make 0, and that's making none of them and missing all of them. But then if that just got that, it would be wrong. What do I do again? Subtract it from what?
1.
From 1. Because 100% chance minus this one is what all the other ones would have added up to. So this is 1. Anything to the 0 power is 1. So that's 1, that's 1. That really means I just have to find 0.2 to the 10th. And that's a ridiculously small number. It's 1.024 e negative 7. That means move the decimal over 7 spots this way. 0.000001024. Would you agree if we're rounding? 1 minus that is pretty much 100%. It's 99.99999%. You don't want to answer the question with there's a 0% chance of that. The probability of at least getting 1 free throw is almost 100%. It's 1 minus a tiny number means 99.9999999, and maybe there'll be a different number down here somewhere. Okay, cool. That is it. You've learned everything that you'd have to know. And then we'll practice it a little bit. And then let's talk big picture for a minute. So today is Thursday. Tomorrow, one new thing called expected value. Never heard of it before. It's brand new. You got to learn it. It's not easy. It's doable, but it's not an easy topic. And then Monday, we'll review for the test, and then Tuesday we'll take the test. I don't see any way for us to try to catch up right now to another class that got ahead of us by a day. It's not that big of a deal, so we're behind a day. It'll be fine. So other classes are going to test on Monday. So don't freak out when you hear there's a test on Monday from one of your friends. True, but we got behind today, and it's totally okay. We'll catch up later. Alright, so we're gonna have a review day Monday and a test Tuesday. I don't like Monday tests anyways, because a lot of times kids forget to study over the weekend and then boom, there's the test and causes a lot of bad scores. So we'll review Monday, test Tuesday. Then what happens for the rest of that week? Review for the cumulative, another review for the cumulative, and then the cumulative. So on Friday of next week. Okay, so next week has 2 math tests. Probability part B, then reviewing, and the cumulative for both probability tests. So next week is an intense week. All right. Let's start up that worksheet. I usually cut it down and make it a little smaller than normal, so if you could open it up, I'll tell you which ones to do. I almost always do problem 1 because I don't want the kid to be like angry that they did problem 1 and then I skipped it. So we'll do number 1. Scroll down a little bit more. Can you scroll up and let me see what 3 is like? We're going to skip number 3. Number 3 is a skip. So we are skipping number 3. Okay, so number 1. Would you read me number 1, please? And just read the directions. I know there's a big chart.
In an illusionist kit, you find a weighted coin that is designed with a 65% probability of coming up heads. You toss the coin 7 times, set up the formula for finding each of the following, then find the probability.
All right, and this is going to be a pain in the neck, except after a while you're going to get faster and faster and faster at it. So what's the first thing they want you to find?
The probability formula.
All right. You mean like the binomial? Mm-hmm. All right. How many do we want to make?
0.
How many times are we going to flip it?
7.
So 7, choose 0. 0.65, and this, I always put like what it is above it. That's make. And then to me that helps me go, oh, so the other one must be miss or not get a heads. You know what I mean? This is like making a heads, missing a heads. And then if I'm going to have 0 heads, that's 0 times that I make a heads. And then the other one must be the other 7. And part of this I can do in my head. If you have to type all this in, it's going to take forever. But anything to the 0, do you get that those are 1? 1 times 1 times, so it's really just this. So then I'm just grabbing my calculator and going 0.35 to the 7th. And that is a tiny number. You got to know how to interpret this. E-4. That means move the decimal 4 spots, and the negative means to the left. So 0.000643. And if somebody asked me to round that to 3 decimal places, be careful, the answer wouldn't be 000, it'd be 001. Does the directions at the top say 3 decimal places? Okay. For future reference, on the test, we pretty much always do 3 decimal places. So just so you know. For now, we can write in anything there as, 000643 is fine. Okay. And then if you're going to do choose 1, it's 7. Choose 1, 0.65 to the 1. And again, I'm going to be smart. I'm going to know this is 7. I'm going to know this is 0.65, so I don't have to type it all in. And then the last part, 0.35 to the 6th. Just make sure you're doing this one right with you. I got 0.00836. Good. Again, usually we only care about the first 3.
Can we just round to the first three?
I'm fine with rounding the first three, so. All right, I think you got the idea. That's all I have for you for today.